So we're back, everyone. And yeah, Tariq is here with me. So we can continue discussions more on testing AI systems and even more in particular, testing them for unwanted bias, which is something that around which has been a lot of talk lately. So yeah, basically, Tariq, I think I'll just give the floor to you.
Thank you, Dan. Let me just share my screen and try to get this going, and we can start. Awesome. Share computer sound. Great. All right. Where to share my audio? Can go there.
Okay, it works. Just
Awesome.
gonna fade out.
Awesome. Cool. All right. Let's get started here. 1 second. All right. So hi, everyone. Again, this is my second Codecamp. I'm pretty excited to be back. My name is Tariq King, as Dan mentioned, and I'm the chief scientist over at test.ai. And, we're going to talk a little bit about AI systems, in particular, this idea of bias in AI, and try to dig into what are some of the techniques or what are some of the things that testers can bring to the table when it comes to testing these types of systems and looking at bias. Hopefully we'll have some time for questions at the end as well, and we'll go through and maybe ask some questions. So quick overview in terms of the agenda. We're going to introduce the idea of bias in AI, and then talk a little bit about that testing perspective of unwanted AI bias, and then get into something that testers love to do, which is quantify the risk of things. And then we can start to look at what are some things that we've been doing to try to help, kind of bring testing to the table as part of AI and AI bias. And then what are some other toolkits and resources that are out there, and then wrap up and have some questions. All right, so there's no doubt that in the world we're seeing, there's a lot around bias, right? We're seeing not only from a lot of the conversations around racial inequality and injustice of recent times, but so many. Our world is kind of filled with these biases. When we start to think about it, it starts with each of us, right? Like understanding what are the things that we may have some prejudices about, and especially those prejudices that we're unaware of, right? This idea of unconscious bias, right? And so in some cases as human beings, we're seeing racial prejudice, we're seeing prejudice against different religions, ethnicities, sexual orientation, and so on and so forth. And it's really becoming a challenge to handle. But even without getting to that extreme, because many of these things, are downright sometimes hatred, we see a lot of different biases in the workplace, or even before you start to hit the workplace. You don't have to go very far to see these things. So I have a short clip here that I encourage you to kind of follow along and see if you can see where your biases lie.
Boss is coming.
Can you take care of this for me?
Sure thing.
Thank you.
Wait, let me guess. You had a very different mental picture in your head when I said boss. Did it look more like him? Don't worry, you're not alone. Our brains make automatic associations without us even realizing it. And while these associations help us make rapid-fire decisions, they can also be influenced by our potential blind spots. Prototype bias happens when we have a preconceived notion of who we think would be right for a particular role based on stereotypes. These mental pictures are based on who we've seen succeed in the past and can influence who we think will succeed in the future. Let's test the theory. Don't worry, just between us. I'm gonna say a word and I want you to point to the word on the screen that you most associate with it. Ready? Let's go. Delicate, powerful, caring, family, career, strong. What just happened? Well, if you're like most people, you associated communal words with female and assertive words with male, because those implicit associations are ingrained in our unconscious mind. A network of researchers from prominent universities developed the implicit association test. This test helps people identify their potential unconscious biases across a variety of dimensions. These types of ingrained associations can often shape our prototypes for who's qualified to lead in the workplace. Take the orchestra. When orchestras started conducting blind auditions in the 70s, the number of female musicians shot up 20%. So either women suddenly played exponentially better when behind the curtain, or the conductors weren't aware they had a prototype bias towards male musicians, and this bias was costing them talent. Another study found that the exact same resumes with more black-sounding names received 50% fewer callbacks than those same resumes with traditionally white names. The idea of prototype bias cuts even deeper than that. Studies show we often have prototypes for the people we believe would succeed in the job, and we may unconsciously change our criteria to help those people get the job. You may be thinking, I'm not like that. Well, the participants in a study on prototype bias thought the same thing. And ironically, those who thought they were most objective ended up being the most biased. Blind spots can span any dimension of diversity and can potentially lead to bad decisions. Not only can blind spots limit our own choices, they may result in missed opportunities that don't lead to the best possible outcomes. The good news is that there are ways to overcome prototype bias. You can start by setting objective criteria. This can help prevent you from being swayed by irrelevant factors. And you can double check your objectivity by sharing the why behind your decisions. Lastly, don't make assumptions based solely on your idea of fit, because when it comes to success, one size doesn't fit all.
So bias, right? Prejudice in favor of one thing over another, whether it's a person, a group, usually in a way that's considered to be unfair. And I like this definition because it says usually in a way that's considered to be unfair. And it brings up a very key point that I like to make, is that not all bias is necessarily a bad thing, right? In many cases, when we start to think about a lot of these systems that we're building these days, and we want systems to be tailored and personalized, right? We want an experience that caters to us. Well, that is a preference, right? Where there's an inclination for the system using machine learning or using AI to be biased, right? But what we don't want is for it to be unfairly biased. And so, you know, a quick search of the internet will show you that there's quite a bit of information out there on bias. In particular, like I did a quick search in preparation for this talk, and there's about nearly 200 different types of cognitive biases that are out there. And it really starts to tell us that, like, this is something that, you know, our world is definitely affected by. And it's something that, you know, you don't have to be in psychology to figure out, right? If you were honest with yourself in that session, and I was when I looked at that video for the first time, you know, I fit that mold. And that's just kind of like how we're trained, right? And our mind, and a lot of it has to do with our past experiences or history and stuff like that. And so overcoming this is first and foremost, you have to recognize that it is indeed a problem, right? And so the challenge becomes is that if our world is filled with bias and we're collecting data from that world and training machines to then act based on that data, then how do we even stop you know, machines from being biased, right? And is that something that's even a practical or feasible task to remove bias from a system, right? And so that's kind of where this focus on unwanted bias and distinguishing that from other forms of bias that may be okay in the system, because it is more that the problem that you're analyzing is okay to have a preference for X over Y, right? But in the cases where that is not okay, how do we kind of detect that and bring it out, right? And that's where like the idea of the bias cycle becomes a core fundamental thing that we should understand, right? Like this all starts with data, right? Us collecting data from the real world, and that data is inherently biased, as we mentioned. But then we actually source and sample and select from that pool of data, which can then introduce further bias into the system. And so data bias is definitely a core part of this problem, right? But then we design algorithms, right? And we build algorithms to then, take the training data and, have some systematic and repeatable way to make outcomes based on that training data, right? And so we're building this machine learning algorithm, and that in itself could have bias, right? We can actually programmatically inject something in there that is not really ideal and serves a preference, right? And we see a lot of these things in search engines and stuff like that, where they're inherently biased in the algorithm, right? Certain things tend to float to the top, whether it be popular items or we present things in an ordered way that kind of leans people to one direction versus the other. And then that's a core part of it. Like people are a third part of this cycle because, your user interface and your user themselves can be the source of bias, right? We just saw all of our cognitive biases and stuff like that. And then we interact with the software, we produce new data, and then that cycle repeats, right? So this is the bias cycle that we see in machine learning systems. And it's good to be aware that this cycle exists, because I think that you have to look at this holistically if you're going to really talk about removing or preventing unwanted bias from creeping in the system, and not only creeping in, but then propagating itself throughout this cycle. All right, so during World War II, and we have a good example here, during World War II, probably about 1943, there was a lot of bombers getting shot down on runs over Germany. And so, of course, back then, the scientists and researchers back then were like, okay, we really need to have some hard data to solve this problem, right? So they went out and they were able to collect, samples of the bullet holes from each damaged bomber, and then actually record that, and then sat down to review it, right? And their mission was like, where on these planes should we reinforce, right? Like, a plane is not something that you can just put armor all around like a tanker, right? It won't actually take off. So you have to be very selective about where you put reinforcements, right? And in collecting this, the data that they had was, very clear, right? This is a clear pattern that, we see all the damage, like a lot of the damage is around the center here. There's damage around the tail gunner, and then there's damage on the wing. So like, they said, this is where we should reinforce, right? We should definitely reinforce these areas, and, we'll have a better outcome, right? And this is a really clear case of when data gives us the wrong solution. And typically when data gives us the wrong solution, it may just be biased, right? And so for them, they didn't realize that, they were kind of missing what they were missing inherently. And what that was that they weren't taking samples from planes that were gunned down, right? All these samples that they were taking were from planes that actually survived. And so it was a Hungarian mathematician, Abraham Wald, that looked at it and said, gentlemen, you need to really put more armor plate where the holes aren't, because where the holes are on these airplanes are actually holes that, are planes that returned. But the planes that didn't return are the ones where they probably had holes in the other areas, right? And this is a classic idea of what's called survivor or survivorship bias, where we tend to focus on those cases of things that survived, right? Like, Mark Zuckerberg and other people, and Steve Jobs, like they dropped out of high school. So, I can drop out of high school and make it, right? But you're not considering all the people that dropped out of high school that didn't make it, right? And so we have to start recognizing that these biases exist, and as a testing community, starting to think about how to tackle this. And it all begins with just figuring out what this stuff is all about. And so this is Ricardo Baeza Yates. He's Director of Graduate Data Science at Northeastern University in Silicon Valley. also the former CTO of a company called Intent, which is a tech company for searching, search tech company. He also is the former VP of Yahoo Labs, research at Yahoo Labs. And I recommend like just checking him out. If you're looking for resources, he has a couple of videos online. He has publications and some other links, and that's a good start. A lot of this work that I've done has been based off of a survey paper that I found from Arabi et al. From December 2019. So a pretty recent survey paper with a lot of categories. So just some resources for you guys to kind of get started in this world of AI and bias and starting to learn what is out there. But from the testing perspective, what can we bring as a tester or as a testing community to this problem? And it's really about getting to a place where we can apply some of the lessons that we've learned, some of the things that we're good at to this world of machine learning when it comes to AI and bias, right? And so you'll see here, we'll kind of move into what from my perspective has been a journey to start to look at this problem and help to improve systems that have to have this type of training data. And so the first thing is that I came up with a set of mnemonics, and if you're not familiar with them, mnemonics are memory aids, right? Things that help you to remember something pretty easily. I remember from my days, it was like for math, these things were very popular. Never eat shredded wheat was one for me for the cardinal points, north, east, south, and west. But I thought, why not come up with some mnemonics that we can just have as testers to help us remember the different categories of biases, right? And so it kind of starts in the middle here, where I talk about this being a daunting task, right? And so here, AI and testing to help us to remember the bias circle. We have data, algorithms, and then user interaction. And then you have, as part of this, the selection and sampling, which I kind of separate out. So the whole thing here is that testing AI daunts machine learning engineers or data scientists and stuff like that, because this is a gargantuan task. Moving on from that, there's the idea of chat, right? So cultural, historical, aggregational, and temporal bias, right? And even within cultural, there's quite a bit. So I broke that out into a nice formula that says culture is greater than language and geography, right? Which is just my creative way of saying, hey, your culture is more than the language that you speak and where you come from, right? There's, and this greater actually is part of the mnemonic, right? So gender, race, economics, age, tribe, education, and religion bias, right? And so you can kind of see how I fit this over the cycle here and kind of try to use things from computing, right? Or mobile technology, SMS, right? Or MOV file types, peers in a peer-to-peer network. And I wanted to round it off with something, no mnemonic is kind of final, or mnemonic list is final without like some random rhyme, right? And so here for user interaction bias, I have some people only like buying cool products, right? For social, presentation, observer, linking, behavioral, cause effect, and production bias. And so you can take a look at these. Again, I found like once I actually wrote this and I had them, like it was like that, and I could roll off all these different types of bias. Of course, the trick then is to know what each of these means and what it represents and stuff like that. And I'll kind of show you how we tackle that. The second heuristic that we kind of came up with was a questionnaire checklist. And at test.ai, we do quite a bit with obviously building AI systems, right? But we're building AI systems to test, but we also have to test those systems, right? And bias becomes important. One of the bugs that we found the other day was that customers were experiencing and mentioning was that, we were automatically generating labels for elements on their application, right? And we were automatically applying those labels, right? And in many cases, the users were just taking those labels by default and not necessarily labeling things themselves. And so there was an algorithmic bias that was inherently propagating through the system because those defaults were automatically applied instead of being suggestions, right? And so we changed our system to do that, right? But it is just a good example that if you don't have you know, a checklist of questions, if you don't have certain things that you know to look for, bias will creep in, right? And so what we've done over the last few months is actually just compile these into a list of questions that your engineers should be able to start asking, right? So do you actually, well, first of all, is there bias in the system? Of course, yes, there's bias, right? But that's just a freebie. Like, how do we actually get towards the unwanted bias, right? So it comes to us understanding what bias is there, knowing how we split our data and different things, looking how we select features and stuff like that, understanding about relevance and looking at different dimensions, hyperparameters, outliers, the weights, everything that deals with that. So, you know, our CEO, Jason Arbin, says, like, if an engineer cannot answer these questions, it's likely that the system produced actually contains unwanted and possibly even liable versions of bias, right? So when you're building, like, you should be able to really filter through this information and know and understand and be able to articulate where you are and what you've done, right? But of course, like any kind of software engineer, we like to build tools to help us, right? And so when I started to look at this initially from a testing perspective, I was like, oh, wow, we should actually really try to get to a place where we can quantify this risk of bias, right? And not just understand and be able to articulate, but if we can actually put a number around it, then that would be awesome, right? And so a lot of my initial work was just, well, how can we just build maybe some sort of a spreadsheet, and it's what you're looking at here, a risk assessment template that asks questions around these different types of bias, and gives you notes about, you know, reminders of what this type of bias is and just a few examples, so that you can start answering these questions. And as you answer questions, the system can calculate bias for you, right? And just with a few Excel formulas, you can start to program in that risk assessment. But of course, that wasn't good enough. You know, I showed this idea to one of my leaders at test.ai, and he was like, oh, wow, we can actually just build a tool, a web application that helps to kind of take that idea and just encode it in everything that we do. And so we launched what's called AI BRAT, which is the AI bias risk assessment tool. And really it kind of follows that bias cycle and looks at those different categories, right? And it follows the mnemonics that we saw and gives you examples of these things, right? So if I just get away from this, I can actually just show you really quickly what this looks like. And so in terms of this, you can start to see like just pop-ups with examples. Here's your cultural bias. What does that mean? And what are some questions that you can start to answer around cultural bias or historical bias, right? And some of these questions are two-part, and we'll get into that. Like, you know, you have no clue about this stuff, right? I don't even know what this is, or I haven't considered it. That's probably a bit of a challenge, but maybe you have done your research and you can kind of filter through. And as you can see, we kind of follow along. We can export to PDF and kind of do this. But the key part of this is that as you answer these questions, as you go through and you start answering questions, you start to see like your risk scores update, right? You start to see this number either fall until eventually, hopefully if I do this right, we'll kind of get down. You say, I now went from high risk, right, which was red, to more of a medium risk, which is yellow, right? And if I continue to improve this, I can eventually get to a place where, you know, my risk in this particular area is green, right? And here we've kind of reduced our data bias, right? And then we can kind of go through and do that. So this kind of serves as a combination of like the heuristics which are embedded in there, right? CHAT, right? Along with, you know, the questions that, you know, might pop up and explanations for what these things mean. And then kind of pulling all that together to quantify and give you a risk score, right? So that's the AI BRAT. It's a freely available, nothing that we, you know, charge for or anything like that. And the whole idea here is that we wanted a system to just take those responses and, you know, put numbers to them, right? And this is nothing new, nothing novel. Any tester that knows about risk and risk assessment knows that we can basically assign, you know, high, medium, low, let that translate into some integers, right? 3, 2, 1. And then we can use a risk matrix like the one that you see here on the left to, sorry, I just switched mode here on my screen. 1 second. Yeah, you can use the risk matrix to then you just multiply the severity here by the likelihood, and you'll end up in one of these regions, and they're color coded according to like the same way that we record them on the website, right? So pretty straightforward, nothing too hard to shout about. Now, the cool thing is that, you know, just from kind of those contributions and doing that work for ourselves and being able to quantify, it also raises the question of what is out there, right? What are maybe some open source tools that are available that allow us to deal with, you know, risk and bias and even mitigating that bias. And so there's quite a bit in terms of tools that are available. All the tech giants, Google, Microsoft, and IBM each have an open source toolkit. Google has the What If tool that's out there that can help you to ask questions and probe and get information on your data points and actually visualize like what these data points look like, and you can start to identify and see where things are off. Similarly, for the Microsoft Sphere Learn toolkit, you can start to see, you know, how your predictions are in terms of things like gender and different dimensions. And then IBM has their AI Fairness 360 toolkit as well, which again, the cool thing that I like about some of these is that they have built into them, you know, mitigation algorithms, right? So with especially the IBM one, when I pulled it down, I could actually apply it to some data set. I can see what it looks like and where I might have bias, and then I can actually mitigate that bias using various algorithms and stuff that are out there for mitigation. So, you know, there's definitely like a movement towards trying to make sure that we have fair AI. A lot of the giants actually feel that we won't have AI if it is not fair, right? There's also a lot of work about making sure that these systems are actually explainable as well, and that's very related to this whole thing. So not only do we need to build these systems where they're, you know, doing what they need to do functionally, we know that they're going to learn, they're going to adapt, that's important, but can we actually remove unwanted bias? And then if these systems actually produce some result, can you actually explain you know, what that particular result, where it came from, or how you came up with that information? And so a lot of these tools actually give us those insights into AI bias and bias testing. And I think it's important. We have some free resources. There's a free ebook. The cool thing that I like about this free ebook is that it's actually free. Like if you click on it and you go here, like you don't need to sign up or do anything. Like you just hit this and you go straight to the Google Drive. No gimmicks. So Jason Arbin, our fearless leader, put together some of his experiences on testing AI and bias. And then a lot of what I've presented here has already been published in an article in Level Up Coding. It's a community of, I think, about 60 plus million coders every month. And so you can check that out. A lot of the you know, experiences and stuff that we went through to build this stuff, and further details on how it works is baked in there. So that's available as well. So what's next, and where do we go from here, right? I think the testing community, as we mentioned in some of the discussions with Isabel and Sue, I believe that the testing community has a great deal, a great piece to play in terms of impact on testing AI and bias, and just making sure that these systems are successful, and that the role of the tester will evolve, right? I think it's up to us to actually come up with these methods for preventing and detecting unwanted bias. And, you know, the work that we've put forward on the mnemonics and stuff like that is the first step towards that, right? I think that there's a lot more that actually needs to be done in terms of testing AI. In particular, looking at coverage models for testing AI systems. There's some work out there on neural coverage, and it kind of just went just a one shot, and that no one has really been looking at it deeply, and not only just looking at it from a research perspective, but trying to bring those things into practice and share experiences on how these coverage models work, or what's useful or what's not useful, and stuff like that. So I encourage you, if you have a testing mindset, to start and give that some thought. And in addition, try to think about contributing to these fairness toolkits, or just pulling down the open source and seeing how it works and running it, and you know, maybe that will lead to some new idea, right, or invention that you can kind of take from there. So just want to say quickly, like, you know, I get to present a lot of these things, but there's a whole team of people who are working hard. In particular, Diony Santiago did a lot of the work on the AI BRAT website. Encourage you to check it out, and look for anything else that, you know, we might bring to the forefront. There's also a community that you can check out, aitesting.org. Just an open source, kind of open information community for sharing things on AI for software testing. So you can also check that out there and stuff like that. So that's all I had here. I think we might have time for some questions.
Hey again, Tariq. Yeah, thank you for this. I have the feeling that I don't know, the more we do in this field of AI, the more challenging it becomes, and then we're faced with new and new problems. I want to go back a bit to the title of your session, and then ask, because bias is already something with a, let's say, negative connotation. So it's a prejudice, or you favor something or a person. And it said, okay, testing AI systems for against unwanted bias. Is there such a thing as wanted bias, or bias that you want to introduce by design?
Yeah, I actually think there is, and that's why I like the term that it just uses, likely, right? Because you know, you're right. Like, bias generally tends to take a negative connotation, just like the word prejudice does, right? Like, is there any good prejudice, right? But if we use the word preference, then we don't have that negative connotation, right? Like maybe Dan prefers to eat pizza on Tuesdays, and some other people prefer to eat tacos. I might be talking in stereotypes here, but that preference is not necessarily a bad thing. Now, if I take that same example, and I assume that because of your ethnic background, you always eat tacos on a Tuesday, then that is definitely not wanted, right? But if I'm trying to make suggestions for Dan, it might be okay for me to give you pizza on a Tuesday, because I've learned that about you as a, I hope you're not eating pizza on Tuesday, but
No,
I've
it's
learned
Wednesday.
I've learned that about you based on the data that you've provided me, right? As opposed to something that is really could be harmful because it's based on stereotype or based in you know, fiction, right? So
yeah, so then that's the I think that's one of the problems, because you build your data sometimes based on the users of your system or previous data that you already have. Yes. And yeah, in this case, if your, let's say, app or whatever targets a group of people that, like you said, prefer pizza on Tuesdays, then if I'm a new user of this app, then I will get recommendations for pizza, because yeah, I'm a minority in this group.
yes, yeah, and that's the thing. We have all sorts of stuff to think about, and that's why, like, I wanted to come up with the mnemonics, because you're talking about, like, yeah, the pool of data that you have in terms of, like, your selection may not be representative of the entire population. Furthermore, the time that you grab that data, there's temporal bias that's involved there. Just the time of day that you might have grabbed the data, or the time of year, like it's election time here in the United States, right? Grabbing a certain piece of data is not necessarily representative of a different time that you grab this information, right? And so it was really more, how can we actually just become more aware of all these different types of bias? Because we're pulling this data, as you know, you work in this field as well. We're pulling this data and we're using it to train systems, right? And if we don't actually tackle this part like a testing problem, we could be liable for, some damage to the community, to some individual group, as a organization, we could be liable.
Yeah, from this perspective, I think I really liked the tool you showed in your talk. I think the first advantage of using it is that it makes you aware of what possible bias you might have, or it makes you think, yeah, do I have it or not? Or do I know what the possible sources are?
Yeah.
So that's good. Here's another thing. Do you think, for instance, that explainable AI can aid in avoiding bias? Or let's say, to start with, do you believe in explainable AI? Because some people don't.
Yeah. So just to remind folks, so when Don is talking about explainable AI, is really a branch of investigation into making sure that these systems can somehow provide an answer for, why they made some decision, right? There's a number of challenges there. Whether or not I believe it might not be a very binary answer to that, but the first thing that you have to look at is that when you start talking about an explanation for something, the audience matters, right? So the way that I explain something to you versus the way that I explain it to my 7-year-old is
It's probably
hopefully
the same.
usually very different. So explainable AI, I do believe that it has a role to play, right? The challenge that I see in that world is that the machine, in terms of the volume of data and everything is processing, trying to actually give us an explanation sometimes that we can actually interpret is one of the first big challenges of explainable AI, right? Just because even as human beings, like that volume of data, like what it's doing, like it's very hard. But I'm also a tester at heart, so I believe that there's no way you can actually test something and make sure it works without being able to observe what it's doing and understanding the system to some degree to verify and validate the result. So definitely it has a key role to play. I believe that there's work there that will help the task of preventing and testing the system for bias. But there's a long way to go to make that something that I think is very useful. But with anything, I think we just start a little bit at a time, right?
Yeah, and then I think it's a bit of a paradox here, and that's what some people are, or quite a few people are saying, because we use AI for problems that we cannot solve on our own or through traditional algorithm or programming. But then, because we don't know what the paths are and we don't know how to get there. But then if we can explain it, and then why don't you use the explanation in the first place?
Yeah. I think the key there is that we might not be able to come up with it, but hopefully we can understand the solution that is told to us, right? But we first have to be able to teach the system how to tell us the answer, right? So you're right, it's a big cycle there. And again, not an easy task, but there's hopefully some very smart people working on it, right? Smarter than me.
Sort of reverse engineering it.
Yeah.
I think we're talking about challenges. In your field or in the work that you're doing now, and even if we move forward towards this particular topic with detecting unwanted biases, what's the most challenging problem you had to solve and one that you solved it?
Yeah, so the work that I'm doing now, like I'm leading a team that builds a platform that leverages machine learning to do automation, right? And I'm trying to test things that have not been automated before per se, right? And so there's quite a bit of challenges with that stuff, and I can kind of just drill into a few. But traditionally, when we think about automation, we think about Selenium, we think about clicking here and clicking there and selectors, and of course, there's automation at the API level and so on and so forth. But tasks, like you said, that normally we can't procedurally script up, like how do you test that a user design is good or bad, and how do you automate that, right? Those are things that we can train the machine to do, right? And that we have trained machines to do, to be able to understand what are some of the guidelines or some of the ratings that human beings would give to that, and then getting the machine to simulate that, right? So things like user design testing, and also testing video quality, testing games. We've been looking at that, and so especially the gaming aspect of it is uniquely challenging because of you're talking about you know, a very uncomfortably infinite problem where, you know, normally we have a certain amount of elements on a screen if we're testing an application functionally, but with a game, you interact with this character, you have thousands of other people interacting, and especially now during COVID, everyone is at home playing games. So it compounds the problem. So I think a lot of the challenges that we've been seeing is actually not just actually applying machine learning to these problems, because we're actually able to train classifiers to do these new things. But now what I'm seeing as my biggest challenge is actually related to testing these types of systems, right? And that's where a lot of my newer work is going to probably end up, in the realm of testing AI machine learning systems. How do you know that, you know, the testing you've done as well? When the testing moves into the runtime environment, how do we know these systems aren't going to freak out on us and eventually take over the world, right? And that's what everyone is worrying about. And I'm worried about that to some degree as well. But I try to just at least contain it one problem at a time. So definitely technical challenges around not really building these systems. Again, of course, there are some, but there's such a wealth of information or research on AI out there that bringing it into the testing world is not the hardest thing ever. But then once we do bring it in, and you're not held by a standard, right? Like I have test.ai on my t-shirt. Yeah, did you test the system that you're building, right? And that's testing my system. That is definitely a key challenge.
Right, indeed. So in the old days, you had testers that tested the system, but now you need to test the system that's testing the system. And then maybe we'll get other layers.
Yeah, hopefully we don't have, it's all the dives that we have to write tests, and then we need to write tests to test the tests that we wrote. And, you know, you try not to do that. You try to write tests that are simple and stable. But in this case, we have no choice but to try to find a way to validate it and train it and keep it up to date. So.
Yeah, so again, like we were talking with Isabel and Sue, I think for those who think that, eventually testers will be replaced by scripts or systems, that's never going to happen. There's always something to be checked.
Yep.
But indeed, Tariq, it's very exciting, and we'll be following your work in the future. I, for one, will. And we're looking forward to having you at other events and conferences, sure. Regardless whether it's online or in person. I think we need to keep learning.
Definitely miss Romania this year, but it's good to still see you guys and to see Codecamp going strong, and encourage the delegates to continue making the best of it, and wish you the best, Dan. So thank you.
Thank you, Tariq. And thank you all for watching. We'll regroup in, I think, 17 minutes now. All right. See you soon, Tariq.